All right, so we're into lesson 1.4, day 1, which our overview. Um, Basically, what we're going to be able to do after today is we're going to be able to solve single variable equations with variables on both sides. So we've been solving one and two-step equations. Now we're dealing with variables on both sides. We're going to add a step in today. Our warm-up is going to teach us how to simplify. Again, this should be a review of a skill that you saw last year, a review of a skill that you've seen in previous lessons, but we want to go over it and make sure that we can do this before we jump into multiple step equations today. So the first equation, ignore that little 2 under there, it's just a copy mistake, but it says x plus 10 plus 6x minus 7, and we want to be able to simplify these. Now, we can't combine everything. We can only combine what we call like terms. So I'm actually going to go through with my highlighter tool, and I'm going to highlight what I mean by like terms. So this x and this positive 6x are considered like terms because they have the same exact variable parts. And in addition to this, the 10, the positive 10, and the negative 7 are considered like terms because, again, they have the same variable parts because they don't even have a variable part. They're considered what we call constants, and constants are always like terms. So I'm going to combine my variable parts first. So x plus 6x gives me 7x. Notice I'm not writing 7x squared. I think of it as like, I don't know, what starts with an x? I have one x-ray machine and I have 6 more x-ray machines. And I now have 7 total x-ray machines. I don't have something other than an x-ray machine. So it's just 7x. Then I combine my positive 10 and my negative 7, and 10 minus 7 is positive 3. So if I combine those correctly, I get 7x plus 3. And that would be simplified. I can't do anything else because these are expressions, they're not equations. I stop there. Number 2, I actually have distribution that I have to do. So I draw on these little rainbows to remind me that I have to distribute the 2. So I get 14x minus 16 plus 5x. And then now after distribution, I'm going to highlight my like terms again. I have only one constant this time, and I have 2 variable terms that have the same variable, 14x and 5x. So if I combine 14x and 5x, I get 19x, and there's nothing to combine with my constant, so I get 19x minus 16. And that is my final answer. And that's the end of the warm-up. Now we're going to move into the shared lesson. All right, so let's look at our first equation. When I teach solving equations, I always teach my students about this acronym. It's called DCGAM. And these are the steps I always take to solve any multiple step equation. And what these letters stand for is pretty simple. D is distribute, C is combine like terms, G is get the variable on one side, which is something that we're going to do for the first time in these lessons. A is add or subtract your constant, and M is multiply or divide by your coefficient. And if you follow these steps, you will be able to solve pretty much any equation that you come across. Now, some equations, when we get into really complex ones, you might have to start back over at D a couple times and distribute a couple times if we're clearing fractions or doing things like that. But for the most part, these 5 steps will help you solve any multiple step equation. So if I look at the 5 steps and I look at this equation, I do not need to distribute anything. I do not need to combine like terms, but I do need to get the variable on one side. Now, I know that you can do this in 2 different ways. We could subtract x from both sides, or we could subtract 4x from both sides. What I like to do is always choose the smaller amount of variables, and I call it pick on the little guy. Pick on the little variable. So this case, the little variable is the x. So in order to get it together, I have to subtract it from both sides. I can't just move it and add it, because then I'd be adding x. Again, with equations, whatever we do to one side, we have to do to the other. And if I added an x over here, then I'd have to add an x over here, and then I wouldn't actually be getting them together. I'd have 2x and 5x, and that wouldn't help me. So when I subtract x from both sides, I get -8 equals 3x minus 2. Again, 4x minus x is 3x. If I had 4 x-ray machines and I took one away, I'd have 3 x-ray machines. Now I am done with get the variable on one side. Now I'm going to add or subtract my constant. So I'm going to add the 2. I don't want to touch the 8 because the 8 is on the side without the variable. And I don't want to bring things from that side over to my variable side. I want to get my variable by itself. That's algebra. Isolate variables. So I add 2 to both sides and I get -6 equals 3x. Divide by 3 on both sides. That's my last step, to multiply or divide by a coefficient. Divide by 3 on both sides. -6 divided by 3 is -2. And -2 equals x. The nice thing with any equation that you ever come across is you have an answer key embedded. If you were to plug -2 back into your original equation, it should work. -2 minus 8 is -10. 4 times -2 is -8. -8 minus 2 is -10. So -10 equals -10. This answer works. Good. All right, let's move on to the next one. Couple more steps in this one. Again, I'm going to write out my D, C, G, A, M. Follow those steps. Do I have to distribute anything? No, I get to cross it off. Do I have to combine any like terms? In this case, yes, I do. I have y's all over the place. So I'm going to combine my y's on this side. So 8y and -y, that gives me +7y. I'll rewrite the -11 equals 3y and 8y, that's 11y, so -7 plus 11y. Boom, that's done. Cross the step off. Now I have to get the variable on one side. If you remember from the previous slide, I want to pick on the little guy. Which one is the smaller amount of variables, 7y or 11y? Obviously the 7y is, so I'm going to subtract 7y from both sides. Subtract 7y. Again, I'm just keeping this nice and organized. I'm doing whatever I'm doing on one side to the other side. So if I subtract 7y here, they cancel out. I'm just left with -11 on the left. And then I have -7. 11y minus 7y gives me plus 4y. Got the variable on one side, I can cross that step off now. Now I add or subtract the constant. So again, I'm going to add the 7 to both sides. I want to do the opposite of what's there. Add 7, because -7 plus 7, those cancel out. It's the goal, canceling things out until I'm left with just my variable. -11 plus 7. At that little song you might have heard already. Same sign, keep and add, different sign, subtract. So I'm going to subtract. I get -4 equals 4y. And then I divide by 4 on both sides. Boom, boom. And I get -1 equals y. Because -4 divided by 4 is still -1. And again, I could plug it back in to check my answer. If it was a test or a quiz, I absolutely would be doing that. If I had the time, for sure, because I want to know that I'm getting it right. I have checked it. It does work. We are good. Let's move on. Question 3. Again, write out my acronym D, C, G, A, M. Don't need to distribute. I get to cross that off. And for today, I'm pretty sure, I don't know if we distribute at all. Do I have to combine? Yes, I do. On the right side, I have multiple k's. So I'm going to combine them. K plus 2k gives me 3k plus 6. And on the left side, I get 3k plus 11. It's already starting to look a little weird to me. There's 3k's on both sides. All right, let's see what happens. All right, combine like terms done. Now I have to get the variable on one side. So what does that mean? Again, I'm going to pick on the little guy. But this case, they're both the same. So I'm going to just subtract 3k from both sides. Again, I got to subtract because I got to make sure they cancel each other out. So the k's cancel here, the k's cancel here, and I'm left with 11 equals 6. What? Is that even possible? The variables are gone, which means they are the same on both sides and they completely cancel each other out. So really what I'm left with is a number sentence that says 11 equals 6, and that's not true. So if it's not a true statement, we write the following for our answer. We're going to write no real numbers or no solution. Okay? No solution is one of the other options. Another thing you can do, another way to write this answer, is you can write the 0 with a line through it, which means that there's no number that works. You could also write the empty set, okay? So all of those answers work. There's just no solution that makes that number, that equation work. There's nothing that will make 11 equals 6. It just doesn't work out that way. Okay, so that's one of what we call a special case. Let's move on to the next one. Again, I'm going to write my acronym off to the side. D, C, G, A, M. Draw my line down the middle. Do I have to distribute anything? No, there's no parentheses. Cross it off. Combine like terms? Yeah. I got n's on both sides that need to be combined. Okay? So I got 8n minus 7n. That gives me n, just one of them. So I get n plus 6 on this side. Then I get negative 8n minus 7n. I get negative 15n. Plus 6. I could have written that as 6 minus 15n. It would have been the same. I just chose to write it that way. Again, it doesn't matter. Combine like terms. Just did it. Get variable on one side. Yep, pick on the little guy. In this case, you might say, oh, 15n. That's got to be the big guy. It's negative 15n. So negative numbers are always smaller than positive numbers. So that's the smaller number. That's the little guy. So I got to add 15n to both sides. Add 15n here. Add 15n here. And I get 16n plus 6 equals, since the 15n's canceled out, equals 6. All right, got the variable on one side, I cross it off. Now I got to add or subtract my constant, so I'm going to subtract 6 from both sides. I get 16n equals 0. Huh, is that like the previous problem? Let me see. The previous problem I had 11 equals 6. I didn't have any variables left. In this problem I have 16n equals 0. Some people want to see this and say, oh, it's like what we did before. It's no real numbers. It's no solution. It's not possible. Not the case. We can have 16 of something equals 0. 16 zeros equals 0. So if I divide by 16 on both sides, following my rules, 0 divided by 16. I can divide 0 as many times as I want. If I have $0 and want to give a dollar, give something equal out of $0 to everyone in this class, everybody gets nothing. So my final answer is 0, which is another one of the special cases. Okay, some people don't consider it a special case. I do. I think when the number equals 0, that is a sort of confusing situation, so it's a special case in my world. N equals 0. If I plugged it back in, I would notice that all the n's would cancel out, and I get 6 equals 6, which works. So n equals 0 works. All right, next problem. Ooh, nice. We do get to use all of the letters. Now I'm going to write my acronym off to the side. D, C, G, A, M. First step, distribute. So distribute the 7. So I get 7x plus 42 equals 84. Good. Where did I get the 7x and the 42 from? Well, I multiplied. I distributed it. I sometimes sing a song to my students. Somewhere over the rainbow. Because I'm drawing in rainbows just to remind myself that I have to distribute to everything inside the parentheses. Sweet, distribution done. Don't have to combine. Don't have to get the variable on one side. I'm already down to 2 steps left. Add or subtract my constant. So I'm going to subtract 42 from both sides. Subtract 42, subtract 42. Okay, so now I get 7x equals 84 minus 42, which is 42. Then I divide, because I'm multiplying or dividing, I divide by 7. I want to make sure that my variable is by itself. 7 divided by 7 gives me 1x. 42 divided by 7 gives me 6. Again, I can check my work. I plug 6 back in. 6 plus 6 is 12. 7 times 12 is 84. Good deal. All right. Last one. Multiple steps. Write them off to the side. D, C, G, A, M. All right. Distribute. Got it right there. Draw the rainbows in. You can sing the song. It's probably a little better than my singing. Who knows? 8 times x is 8x. 8 times 4 is 32. Rewrite everything else. 35 plus 8x equals 3 plus 8x plus 32. Draw the line down the middle. All right, distribution done. Combine like terms. Yes, I have to. I have this 3 and this 32 on this side. So I'm going to combine them, and I'm going to get 8x plus 35. Good. On the other side, I have 35 plus 8x. Let me do a little highlighting over here. This is sort of blending. Or I'll just draw a line over here. That's my little cheat sheet over there. That's my acronym. So I've distributed, I've combined my like terms. Now I got to get the variable on one side. So I got to pick on the little guy. Again, they're the same. This is probably going to be another one of those special cases. So I'm going to subtract 8x from both sides. Subtract 8x. And I'm left with 35 equals 35. Before, when the variable canceled out, if you look back at question number 3, hold on, sorry, my computer sort of froze a little bit. Question number 3, like I was saying, which is right here, it wasn't true. It was 11 equals 6, which is not a true statement. So that's why we wrote no real number. So what do we do in this situation when it says 35 equals 35, when it does create a true statement? What that means is, the 8x on both sides, it doesn't really matter because it's the same on both sides. So whatever x is, it's going to completely cancel each other out. If x was 0, it works. If x was 10, it works. If x was pi, it would still work. It can be irrational, rational, just has to be some sort of real number. So every real number works. So our solution here is all real numbers. You might ask, well, aren't all numbers real? Well, when we're dealing in Algebra 1, yes, we're dealing in the real number set, but you will find out later and through some enrichments that we do throughout the year about the non-real number set, and there are ways to manipulate numbers that aren't considered, they're imaginary. But for this, all real numbers is our solution. Another way to write all real numbers, if your teachers allow, is the double backbone R. It's just the symbol in mathematics for all real numbers, which basically again means that you could plug in literally any number you want for x and it'll work because it's going to cancel each other out. They're the same on both sides. Okay. And that is all the lesson for today. Just to wrap it up, remember, make sure you're combining your like terms on the same side. It saves so much time. And be careful when there are special cases. Remember that x equals 0 and no solution are two completely different things. X equals 0, that means you have a solution. It's just that it's 0. No solution means nothing works, nothing at all. Okay, so make sure you differentiate between the special cases. Make sure you're combining like terms. If you like my little acronym with DCGAM, be sure to use it. I'm sure no teacher will have a problem with that. Absolutely use it, and good luck.